All right, in this video, we are going to talk about composition of functions. So again, just like in the previous video, we are going to be taking two simpler functions and combining them together to make a more complicated function. In the previous video, we just used the standard operations that we're kind of used to from our previous math classes, like adding, subtracting, multiplying, and dividing. Those are common, right? And understood those pretty well. This operation, however, the composition of functions, right, is more complicated than those other ones because what we're essentially doing when you do composition of functions is plugging one function into another one, right? And now that might sound weird at first, but if you think about it, right, we've been plugging numbers into functions, right? So we know that functions, we plug numbers in and then you'll get numbers out. And so that's all the composition of functions is we are plugging a function into another function instead of a number, okay? So the notation for the composition of functions is this f and a little open circle g. So some people will call that fog, but it's really, I just really call it f of g or f composed with g, okay? That's how I normally read it. Now you may say, hey, well, why did they choose this little open zero like that to do that? And well, that's what's in math called an operation symbol. So you already are familiar with sum, right? Adding the plus sign, minus sign, the times sign. They can't use any of those, right? Because those are already used for operations that you're used to, right? So this is just a different one, it's just like a plus or minus or times or division sign. You can just think about it like that. It just stands for a different operation, okay? So that's its name, right? F of g or f composed with g. And then over here is the formula, right? The building plans, how you would construct that. Just like what we were talking about in the previous video about combinations of functions. All right, the thing about this definition, though, and one of the things that makes it appealing to mathematicians is that it says a lot of things with just a few symbols, okay? So it has a good expressive power, right? Function notation. That makes it easy to write down complicated stuff, but it also makes it a little bit hard to interpret what those things are saying when you're just learning how this works. So we are going to talk about the directions and what this says, what over here, this expression on the right-hand side of the equal sign says to do the composition of functions. All right, so again, I read this notation as f of g of x, right? Sometimes you'll hear people say f times g, and it's not f times g, okay, this notation here. Even though it kind of looks like you might be able to interpret it that way, it's not. You have to kind of tell from the context of what they're talking about what the interpretation is. If they're talking about the composition of functions, right, this does not mean multiplication. So don't get that confused with multiplication. All right, so now exactly what does this say to do? This basically says to plug g of x into the function f, okay, is what it says. All right, and so I follow these steps to do it. If you talk to other people, they might do it slightly differently. That's fine. But in my mind, I think I've had more success explaining to people using this set of steps than the other way. Okay, so you're going to be given two functions f and two functions g, kind of like this, right? I have two functions. And so what you want to do to form this composition of functions is to replace the function inside, right, which in this case is g of x, by whatever its formula is, okay? So that's step number one in formulating f of g of x. Step number two, everywhere there's an x in the outside function, in this case it's f, right, the one on the left, what you want to do is replace x with the formula for the inside function, and then finally simplify. So there's three steps that we need to go through. All right, let's get to the examples. All right, so here we have f of x equals x squared and g of x equals x plus 2. We want to find f of g. All right, so we start off with our formula, f of g of x. And then the first step, we are going to replace g of x by what we know it's equal to, right? G of x is equal to x plus 2. So that's what I did. This g of x, I just put x plus 2 in there. All right, and then now what we are going to do is everywhere there's an x, right, in this formula, the formula for f, we are going to replace that x by x plus 2. All right, so here is the formula for x squared. You can see I've removed the x out of there, and I've just kind of left a little space in there. And what I'm going to do is I'm just going to take this x plus 2, and I'm going to plug it in that space where the x was. Okay? And in this case, you could multiply that out, but you don't necessarily have to either. Okay, if the directions say they want it multiplied out, then you can multiply it out. But this is perfectly fine as well to leave it like this. All right, so literally what we did was everywhere there was an x, right, in this formula, the formula for f, right, the one on the left, we took and we plugged in that x plus 2. Okay? All right. In the next example, we have if f of x equals the square root of x and g of x equals the rational function x plus 2 over x minus 1, find f of g. All right, so once again, start with our formula, right? And then the first thing that we are going to do, right, is to replace the one that's on the inside, g of x, by what we know it's equal to, right, which is x plus 2 over x minus 1. Okay? And then what is this saying to do? This has f, right, of some expression in here. What you're going to do is go to the formula for f, right, over here. So here's the formula for f. Everywhere there's an x in that formula, we are going to pop out the x, and we're going to replace it by what's in parentheses right here. So pop the x out and plug in the x plus 2 over x minus 1. Okay, and that's it on this one. This one can't be simplified much more than that. Okay. All right, next example. All right, in this example, again, we're given two functions, f of x and g of x, and we want to find f of g. All right, so start with your formula for f of g. All right, and the first step, we are going to replace g of x by what it's equal to, which is x to the 5th. Okay, so next up is f of x to the 5th. So what is that saying? That's saying, hey, go to the formula for f, and everywhere you see the variable x in this formula, which is 2 spots in this one, you are going to plug in that x to the 5th. You're going to replace x by x to the 5th. So if I take this formula for f, right, and think about popping the x's out, that would leave me 2 spaces, right? I'd have a space right here and a space right here, which I just marked with parentheses. And then now what I'm going to do is put the x to the 5th in those parentheses. I'm literally plugging in the x to the 5th, right, into that formula. So it's going to look like this, right? And you can see wherever there was an x in there, now there's an x to the 5th. In this case, we can simplify this expression a little bit, right? Because we have x to the 5th squared. When I have a base raised to a power and all of that is raised to another power, then you multiply the powers together, right? That's what one of the laws of exponents says. So x to the 5th squared is x to the 10th. And then over here in this middle term, the parenthesis, right, since there's really nothing being added or subtracted in here, you can just kind of get rid of it. All right, this is just 4 times x to the 5th. Well, so is this. All right, so it's simpler that way. Okay, so that's f of g. All right. In this example, we are going to work a slightly more complicated problem out. All right, so here we have f of x equals 2x minus 1, and g of x equals 3x squared plus 5x. All right, in part 1, they want to know what is f of g of x. All right, so we know the formula is f of g of x, right? And so what I'm going to do is replace g of x, right, by what I know it's equal to, which is 3x squared plus 5x. Okay. All right, and then next, right, I am going to go to the formula for f right here, and everywhere where I see this x, I am going to replace the x by this expression in here. So I had 2x minus 1, right? So what I'm going to do is pop that x out and replace it back with this 5x like so. Okay, and here this can be simplified, right? 2 times 3x squared is 6x squared. 2 times 5x is 10x, and then minus 1. So that's f of g of x. All right, in part 2, they want us to calculate g of f of x. All right, so this is backwards to what we've usually been doing. Usually we've been saying f is this one and g is this one, but there's nothing stopping us from doing it sort of in the reverse manner. You just have to remember which one goes which, right? So in the original formula, f, right, is the one on the left. It goes on the outside. In this case, right, it's g going to be on the outside, right, and f on the inside. So that's the pattern that I'm following there, okay? So this one on the left goes on the outside, and this one on the right goes inside. Okay. So what I would do next, right, is the one that's on the inside, which in this case is the f of x, right? I would replace that by what I know it's equal to. So f of x, right, we know that that's equal to 2x minus 1. All right, next up is I would go to g, where g is right here, and everywhere I see this variable, the x, in this formula, I would replace that x by what's inside the parentheses down here. In other words, I am taking this 2x minus 1 and I am plugging it into g. So everywhere there's an x in g, that x would be replaced by a 2x minus 1. Like so. Now here there is a lot of simplification that we have to do. So let's go ahead and do it. First off, I need to square out that 2x minus 1. So 2x minus 1 quantity squared would be 2x minus 1 times 2x minus 1. Okay, and then over here on the 5, I would go ahead and distribute that through the parentheses. So 5 times 2x is 10x. 5 times minus 1 would be minus 5. All right, next up I would FOIL these two polynomials out. There's different methods for doing that, but I just like to FOIL it. First, outer, inner, last. Right, so 2x times 2x will be 4x squared. Outer will be minus 2x. Inner will be minus 1 times 2x, so that's minus 2x. And last times last will be positive 1. Right, next I have some like terms in here. So that would be 4x squared minus 4x plus 1. And now finally I can distribute that 3 through the parentheses. So I can take this 3 and multiply it times each of those terms in there. So let's just go to the top up here. So that would be 12x squared minus 12x plus 3 plus 10x minus 5. Okay. All right, and then I have some like terms. I can combine this minus 2x and the 10x and this 3 and the minus 5. So I get 12x squared minus 2x minus 2 when I do that. Okay? All right, let's see, next one. All right, the next one is 3, and that is f of x. All right, and so here, again, just follow the same pattern. The one on the outside is going to be f, and the one on the inside, in this case, right, is going to be f. Just like the inside one was g, it's g here. So it's going to be f of x. And we know that f of x is 2x minus 1. So just like before, right, we are replacing the inner one by what we know it's equal to, which is 2x minus 1 in this case. And then what we're going to do is go to f, and everywhere we see this variable and this formula, right, we are going to plug in what's in parentheses. So it was 2x minus 1, so now it's going to be 2 times 2x minus 1. And distributing that out, we get 4x minus 2 minus 1, which is 4x minus 3. All right. And number 4. In number 4, we want g of x. All right, so just like before, it's going to be g on the outside, g on the inside, just like we did the one for f. And I'm going to move way over here, so maybe we'll get this in without having to erase stuff. So replace g of x by on the inside one by what we know it's equal to. So that's going to be g of 3x squared plus 5x. Right, so we're replacing g of x by what we know it's equal to. And then we're going to go to g, right? And everywhere we see this variable in this formula, right? In this case, it's an x. Everywhere we see an x, we are going to replace that x by what's inside parentheses here. So it was 3x squared plus 5x. In this case, right, we are going to replace that by 3x squared plus 5x. And same thing on this one, 3x squared plus 5x. All right, so in this one, again, we have a lot of work to do, right? So it's going to be 3, and then we have 3x squared plus 5x quantity squared, right? So we're going to have to write that out twice and FOIL it out. And then I'm going to go ahead and distribute these out, right? So that would be plus 15x squared plus 25x when I multiply 5 times 5x. All right, and then I'm going to keep foiling this. I'm going to FOIL this out. So 3x squared times 3x squared is 9x to the fourth. 3x squared times 5x is plus 15x cubed. This is also plus 15x cubed. And then last times last is 25x squared. All right, and then don't forget to move that other stuff down too. Okay. Inside the parentheses here, I have some like terms, so I'm going to go ahead and combine those. So I have 9x to the fourth plus 30x cubed plus 25x squared. And then plus 15x squared plus 25x. Then again, I am going to distribute this 3 through the parentheses. So I'll get 27x to the fourth plus 90x cubed plus 75x squared plus 15x squared plus 25x. And then I can finally combine some like terms in here. So I've got 27x to the fourth plus 90x cubed plus, and then 75 plus 15, 70, 80, 90 x squared plus 25x. All right. I do think that is it on this video. Yes. So that is it on this one. And in the next video, we'll talk about what the composition of functions is exactly, and then work through some of the problems in one of the Newton assignments.